Question 6. If alpha and beta are the roots of the quadratic equation 2x squared plus 2x minus 5 equal to 0, form the quadratic equation that have the following roots. We are given 2x squared plus 2x minus 5 equal to 0. A is 2, B is 2, and C is negative 5. And the roots are alpha, beta. Our sum of root is equal to alpha plus beta, which is equal to negative 2 over 2, negative 1. Our product of root is equal to alpha beta equal to negative 5 over 2. A, the new roots are 2 over alpha and 2 over beta. Let's find the sum of root. 2 over alpha plus 2 over beta. We make the denominator the same. 2 beta plus 2 alpha over alpha beta. Factorize the 2. 2 bracket alpha plus beta over alpha beta. We substitute the value inside. 2 multiply with negative 1 divide negative 5 over 2. We get negative 2 multiply with negative 2 over 5, 4 over 5. The product of root is equal to 2 over alpha multiplied with 2 over beta, which is 4 over alpha beta. Substitute the value of alpha beta. Simplify it. And we get negative 8 over 5. Therefore, the equation is x squared minus 4 over 5x minus 8 over 5 is equal to 0. We multiply the whole equation by 5. We get 5x squared minus 4x minus 8 equal to 0. B. The new roots are alpha minus 1 over beta and also beta minus 1 over alpha. Let's find the sum of root. Alpha minus 1 over beta plus beta minus 1 over alpha. We expand the bracket and group them together. Alpha plus beta minus 1 over beta plus 1 over alpha. Then we make the fraction in the bracket into a single fraction. Alpha plus beta minus alpha plus beta over alpha beta. Then we substitute in the value respectively. Negative 1 minus negative 1 over negative 5 over 2. We get negative 1 minus negative 1 times negative 2 over 5, which is negative 1 minus 2 over 5, and we get negative 7 over 5. Product of root is equal to alpha minus 1 over beta multiply with beta minus 1 over alpha. Expand the bracket. We get alpha beta minus 1 plus 1 over alpha beta. We substitute the value negative 5 over 2 minus 2 plus 1 over negative 5 over 2. We have negative 5 over 2 minus 2 minus 2 over 5. We make the denominator into 10. So we get negative 25 minus 20 minus 4 over 10, which is negative 49 over 10. Therefore, our new equation is x squared minus negative 7 over 5x plus negative 49 over 10 equal to 0. We multiply the whole equation by 10. We get 10x squared plus 14x minus 49 equal to 0. Question 7. The equation 3x squared minus 6x plus 1 equal to 0 has roots alpha and beta. 3x squared minus 6x plus 1 equal to 0. Our A is a 3, B is a -6, C is a 1, and roots are alpha and beta. A. Write down the value of alpha plus beta and of alpha beta. The sum of root is equal to alpha plus beta equal to -b over A equal to 2. The product of root is equal to alpha beta, which is C over A, 1 over 3. A second equation, x squared plus bx plus q equal to 0, has roots 1 over alpha and 1 over beta. Find the value of p and of q. Our A is 1, our B is a P, and our C is a Q. Let's find the sum of root. Sum of root is equal to 1 over alpha plus 1 over beta, which is beta plus alpha over alpha beta. Substitute the value of alpha plus beta and alpha beta that we obtained in part A. We get 2 over 1 over 3, which is 2 times 3, 6. And according to this equation, sum of root is equal to -b over A, which is -b. Therefore, b is equal to -6. The product of root is equal to 1 over alpha multiplied with 1 over beta, which is 1 over alpha beta. Substitute the value of alpha beta, and our product of root is 3. From the equation, the product of root is C over A, which is Q, so Q is equal to 3. Question 8. The roots of the equation 3x squared minus 5x plus 1 equal to 0 are alpha and beta, while the roots of the equation 27x squared plus hx plus k equal to 0 are alpha plus beta and alpha squared plus beta squared. Find the value of h and of k. Here we have two equations. The first equation is 3x squared minus 5x plus 1 equal to 0. And the roots are alpha, beta. The second equation is 27x squared plus hx plus k equal to 0. And the roots are alpha plus beta and alpha squared plus beta squared. We are asked to find h and k. The A for this equation is 3, B is -5, C is 1. And for the second equation, the A is 27, B is a H, and C is a K. Let's start with the first equation. Sum of root is equal to alpha plus beta, which is -b over A, 5 over 3. Product of root is equal to alpha beta, C over A, 1 over 3. For the second equation, the sum of root is equal to alpha plus beta plus alpha squared plus beta squared. Recall, A squared plus B squared is equal to A plus B squared minus 2AB. So for the sum of root, we have alpha plus beta plus alpha plus beta square minus 2 alpha beta. Substitute the value of alpha plus beta and alpha beta we obtained just now. We get 5 over 3. Add with 5 over 3 square minus 2 multiply with 1 over 3. We get 5 over 3 plus 25 over 9 minus 2 over 3. Let's make the denominator into 9. We have 15 plus 25 minus 6. We get 24 over 9, which is 8 over 3. According to the equation, our sum of root should be equal to -b over A, which is -h over 27, Therefore, our h is equal to 8 over 3 multiplied with negative 27, and we will get negative 72. Let's find the product of root. Alpha plus beta multiplied with alpha square plus beta square. We will get alpha plus beta multiplied with alpha plus beta square minus 2 alpha beta. We substitute in the value 5 over 3 multiply with 5 over 3 square minus 2 multiply with 1 over 3. We get 5 over 3 multiply with 25 over 9 minus 2 over 3, which is 5 over 3 multiply with 19 over 9. From the equation, our product of root is c over a, which is k over 27. So therefore, our k will be 5 over 3 multiply with 19 over 9 multiply with 27. Therefore, our k is equal to 95. Last question, question 9. The roots of the equation x squared minus 7x plus h is equal to 0 are alpha squared and 6 over alpha. X squared minus 7x plus h equal to 0. The roots are alpha squared and 6 over alpha. Our a is a 1, b is a negative 7, and c is a h. A. Given that the roots of the equation are unequal, express h in terms of alpha and show that alpha cubed minus 7 alpha plus 6 is equal to 0. We find the sum of root and the product of root. The sum of root is equal to alpha squared plus 6 over alpha, which is equal to negative b over a, 7. And our product of root is alpha squared multiplied with 6 over alpha, which is equal to c over a, h. We are asked to express h in terms of alpha, so let's continue from here. We cancel the alpha, we have 6 alpha is equal to h. We need to express h in terms of alpha, so we make h our subject, so h is equal to 6 alpha. For the sum of root, we simplify it, we multiply the whole equation with alpha. Alpha cubed plus 6 is equal to 7 alpha. We rearrange it, we get alpha cubed minus 7 alpha plus 6 is equal to 0, hence shown. B. Solve for the equation alpha cubed minus 7 alpha plus 6 equal to 0. Alpha cubed minus 7 alpha plus 6 is equal to 0. This is a polynomial equation, so we need to do try and error to get our first root. Let's try alpha equal to 1. So we let alpha equal to 1. 1 cubed minus 7 times 1 plus 6 is equal to 1 minus 7 plus 6, which is 0. Therefore, alpha equal to 1 is a root for the equation, and it will lead to alpha minus 1 is a factor. We can rewrite the expression alpha cubed minus 7 alpha plus 6 into alpha minus 1, a alpha square plus b alpha plus c. Then we expand the bracket. The reason we do so is to compare the coefficient later. We expand the bracket, we get a alpha cubed plus b alpha square plus c alpha minus a alpha square minus b alpha minus c. Then we collect all the like terms together. We have a alpha cubed plus b minus a alpha square plus C minus B alpha and minus C. Then we compare the coefficient A alpha cube with alpha cube. We get A is equal to 1. We don't have any alpha square over the left side. C minus B alpha is equal to negative 7 alpha. C minus B is negative 7. And lastly, minus C is 6. Negative C is 6. Therefore, our C will be negative 6. Substitute C equal to negative 6 in this equation. Negative 6 minus B equal to negative 7. B will be negative 6 plus 7, which is 1. So we can double check, since we don't have any alpha square value, B minus A must equal to 0. Here we obtain B is 1, A is 1. 1 minus 1 is 0. So the values of A, B, and C that we get is correct. Now, for this part, we can write it as alpha minus 1, alpha square plus alpha minus 6. Don't forget our purpose. We need to solve for the alpha. So alpha cube minus 7 alpha plus 6 is equal to 0. We rewrite it as alpha minus 1, alpha square plus alpha minus 6 equal to 0. Then we continue factorize the bracket. Alpha square will be alpha and alpha. For the 6, we have 1 and 6 and 2, 3. Let's try 2 and 3. Here we obtain 2 alpha. Here we obtain 3 alpha. If we add them, we will get 5 alpha. If we minus them, we'll get alpha. Alpha is what we want. Plus 3 minus 2. The positive follow the 3 alpha. The negative follow the 2 alpha. And lastly, need to check negative, positive will give us a negative. Alpha minus 1 is equal to 0, alpha is equal to 1, or alpha minus 2 is equal to 0, alpha is equal to 2, or alpha plus 3 is equal to 0, alpha is equal to negative 3. In part A, we are told that the roots of the equation are unequal. So alpha square and 6 over alpha should be unequal. So we need to check the values of alpha that we obtain satisfy this condition or not. Checking the roots are alpha square and 6 over alpha. When alpha equal to 1, alpha square is equal to 1 square, which is 1. 6 over alpha will be 6 divided by 1, 6. When alpha equal to 2, alpha square is equal to 2 square, 4. And 6 over alpha will be 6 divided by 2, 3. When alpha equal to negative 3, alpha square is negative 3 square, 9. And 6 over alpha is equal to 6 divided by negative 3, negative 2. Seems like all the roots are not the same. When alpha is 1, the roots are 1 and 6. When the alpha is 2, the roots are 4 and 3. And when the alpha is equal to negative 3, the roots are 9 and negative 2. So we don't have any equal roots. Hence, all the answer for our alpha is accepted. So that's it for today's tutorial. Hope it will help you in your study. See you again in the next video.